There you go. Yes, last week I forgot. So I spent about 43 minutes redoing it again, but I think I got the gist of everything here. So Anne promised that she wouldn't let me forget this time. So and she didn't, matter of fact. So all right. So what I'm going to do is let me share my screen. I'm going to share my screen and uh share screen. And we'll look at the agenda here. Okay, I'm assuming everyone can see my screen. Okay, so well, I'd first like to shout out if there's anyone that this is their first meeting, if you could just introduce yourself, because we're getting different people at different times, and we're adding more and more folks from all over, literally all over the country. And one of the beautiful things is that if you're on this team, you are a thinker. You are pushing the industry to the next level. We all have that in common. So just know that. And it's whether it's through conferences or through academia or private industry, all of you have a reputation of being very good at your sector of the industry and really dedicating your journey, your career to making things better. So with that said, it's always good to now know who our team is. And so the first one we introduced ourselves, and so we'll make it a habit as we for every meeting we'll just go through a quick introduction. So maybe Amir, I'm not sure that why don't you start, and then pretty much if you haven't introduced yourself at any of the previous meetings, just introduce yourself. What's your sector or lens? What's your expertise, like IPD, just in general, means and methods, estimating, that type of thing. And why are you curious? What piqued your curiosity about being part of this pretty cool study? So maybe Amir, maybe you can start, or I should say Dr. Savinci.
Thank you. Good afternoon, everyone. This is probably my first session. I missed a couple of weeks. I had physical therapy, which I ended up changing the time. So I'm glad to rejoin the group. My name is Amir Zavici. I'm Senior Construction Manager, Port of Los Angeles, in Southern California, doing project management for $1 million projects. And I'm teaching cost estimating with Paul Martin at UC Davis now as well. I'm just excited to be part of this group every time. We are doing something great, and we are just improving ourselves as part of the team. So excited to be here.
That's great. Thanks, Amir. Who wants to go? I can go. Well, yeah, go ahead, Jeffrey. Sure. That's great.
Hey, everybody. Jeffrey Nelson. Paul and I have worked together a couple of different times on past projects. I'm in the construction industry. Last 30 years have kind of seen the entire gamut of seats in the construction industry, from the owner side to the regulatory side to now the general contractor side. Tend to focus on very large healthcare projects, but I would say a specialty is integrated project delivery. The focus on target value design and decision making in complex or fluid kind of environments. So nice to meet you all.
That's great. That sounds very familiar, doesn't it, guys? Folks on the team, because that's one of the big parts of this whole thing. So welcome, Jeffrey. It's good to see you.
I'll go next.
Yeah, please.
So I'm Kyle Holmes, not Olivia Holmes. It's my daughter used my computer last, so I didn't sign her out. I'm with Southland Industries. I'm actually in the Texas office. I was with Brandt before Southland bought us about 2 years ago. I've been with Brandt and now Southland about going on 26 years. My specialty is MEP construction. I literally start out in the field in a plumbing crew. I have an engineering degree. I worked as an engineer, assistant PM, a PM, and then I was our chief estimator for about 10 years. I started our BIM group and then our FAB group. And then I moved into the corporate services, which is just go fix things that are broken. So that's kind of my specialty. And I'm learning the Southland universe. And that's how I met this team, because someone that Paul knew at Southland couldn't join him at a conference, but said, "Hey, hit this Kyle guy up." And that's how I met Paul. So glad to be here.
Well, Olivia, just kidding.
You can call me whatever you want.
I just kidding. Hey, Scott or Kyle, we had the pleasure just to the team of really getting to know each other, prepping for a conference. And this guy is this guy's a thinker, man. So I'm really and his expertise is rolling top technology into pre-construction and how that ties into technology. So this is just absolutely outstanding. So it's good to have you, Kyle. Scott, welcome.
Yeah, thanks everyone. And thanks so much, Paul, for extending an invitation to me. Yeah, Paul and I connected in an LSIC workshop. And, through that, I was able to get an invitation to join this meeting. I'm very, very excited to be here. I'm an engineer by background. I'm a licensed engineer. I live in Western Canada. Most of my work has been focused on project management, which has always included estimating in one way or another. I work for a relatively large international corporation based in Alberta, ATCO. One of ATCO's primary businesses is utilities, electricity and natural gas, among other things. I've worked for ATCO Electric, I worked for ATCO Gas, and I now have the privilege of working for a small group called ATCO Space Lab. And we do a few different things, but one of them is look at future opportunities and new technology opportunities for ATCO. And yeah, I'm excited to be a part of this group and I guess contribute to a future in the lunar environment. So my exact level of involvement still kind of TBD discussion with some of the people I work with, but I'll be involved in some way and happy to be here.
Yeah, I keep telling people it's good to have you. I keep telling people, because we're all busy, we're all in management, and and when somebody joins a team, it's like, gee, how much time? It's intriguing. And I keep saying, their only expectation is that there are no expectations. You just do what you can do at the moment. So, and we're trying to make the process easy for you. Is there anyone else?
Yeah, Rashid, I haven't. First time here.
Oh, good.
So, hey, everybody. And
Hey.
I think likewise, I also connected with Paul at the most recent LSIC lunar landing workshop. So thanks for inviting me. So I work for Bechtel. We're a very large engineering procurement construction company. We've got, end-to-end delivery in sectors like infrastructure, mining and metals, energy, manufacturing technology, government. So do a little bit of everything. My personal career, I've got a degree from electrical engineering. So I started off in control systems, doing nuclear waste processing, and then got my professional engineering license and completely changed my whole career course. I went to business development for 4 years. So a lot of time doing budget analysis, proposals, estimates, strategy, and then ended up joining one of the projects I won, Sentinel, speaking of mega programs that are overrunning, and was there as a system engineer trying to help with requirements analysis. And then most recently joined our newest division, which is manufacturing and technology. And we're doing things like semiconductor production, EVs, batteries, advanced material production. And I guess for the past 4 or 5 years of my company, I've always been kind of involved in the space end since we have been involved. But yeah, my skill sets obviously the past 12 years a bit all over the board, but I think that might be good for this group. I can offer perspectives from the business side or technology side. And I guess for this, why I'm interested in the group is just, I think the LSIC calls are great. They're very technology focused, but I think for a sustained lunar presence, right, we're going to need to have the business end of the deal worked out. So having an estimate in place, understanding the logistics, the money portion, right, that's kind of what enables technology deployment and sustained presence. So yeah.
Yeah, agreed. Well said. Well said. Thanks. And just so, because we're going to be hearing this a lot, the term is LISIC, or some people pronounce it different things, but it's called Lunar Surface Innovation Consortium. So you'll hear that a lot from NASA and also Johns Hopkins Applied Physics Lab and folks that are involved with him. So the last two colleagues that introduced themselves, they're at a spring conference with that group that's hosted by NASA and Johns Hopkins. And pretty much everyone there are with companies that are, for the most part, inventing technology for either infrastructure or habitat or structure or whatever it is to apply for the moon for moon missions. So anyway, just to give you context, because you'll hear that quite a bit. We should put that in the data room also, as far as and maybe just a definition page of acronyms would be good. And that will be our first one. So, okay, very good. Is there anyone else that would like to introduce? If you haven't introduced yourself in previous meetings, otherwise, let's move on to the next one. Keith, it's good to see you. Okay, let's go to current events. And is there, I'm sorry, I didn't mean to talk over it. Was there someone that wanted to introduce themselves? We good? Okay. Okay, good. Let me see here. So current events, this group has been contacted by a TV show called Advancements, which is, it's called Advancements with Ted Danson. They focus on technology in different sectors. It's streamed on Prime, and it goes to 375 million worldwide households. They want to do a feature segment on our research project. And so it's currently being pitched by the senior producer. It's been given a high level of success. And on the data room, some of you yesterday received the structure of description of what we're doing. That was submitted to the TV production team, and we'll post that in our on the data page, and we'll do that. It will be called Advancements with Ted Danson description, episode description. Why I would encourage you to read it is because it really gives you the depth of what we're doing and the importance, not only just in the construction industry, but aerospace, and also it just involves a lot of lenses and people getting involved. So it's a big deal. But anyway, you'll get a sense of that when you read the document. So that's pretty cool. Stand by. We'll, we'll keep you informed how this is going, but we've been talking off and on for about a month, but it got serious a couple days ago, and now the director's involved. So we'll let you know what that means, but it's a pretty cool opportunity. And it's, again, going to feature the work that this team right here is doing. Taping could be as soon as February. So, but there's a lot that has to be done prior to that. So, okay, so let's go back to the agenda. That's current event. Thank you, Mark. I'm not sure if you're on there. Mark is director at NASA. Heard about this and really submitted an email to a group of us that congratulated us for this invite for such a show. So next is let's talk about organization of the research data room. I'm going to keep this quick because we mention it at every meeting. When peer reviews, there's spelling errors on this, and that's seems to be common with me. Sometimes I type fast and I'm a poor reader to begin, or speller to begin with, but that's supposed to say peer review. You know, it's a typo. But anyway, that essentially the white paper, when we get a draft, when the draft is complete for peer review, instead of just everybody peer reviewing and we're kind of all over the place, we'll have a process of how we peer review to keep your to really acknowledge what you are an expert in, what's your lens of expertise. And when you do the peer review, you can isolate specifically, you know, what your expertise is, and there's so many people on the team, we need to keep this organized. So we'll have a process put together by the time that the draft white paper is articulated. The peer review is going to be the time where you really get in deep and just tell us your thoughts. And you can record them, you know, on a Zoom call or whatever. It can be a video, it can be Post-it notes, whatever, and we'll make it really cool and easy for you. And then we'll keep diving in, you know, the meat and potatoes that we need to reach. But, you know, we don't want this to be a traditional thing where here are 10 pages of the white paper, do your peer review. We don't have time as a collective. We just, all of us on this call. So that's why we're being really cognizant of coming up with a process that will be easy for you to just focus on your expertise and go to the place that you need. The next is reference documents. I want to remind you, if there's any reference documents that you'd like to contribute, there is a form you just fill out and give it to Anne, who's the intern for the summer for the Institute, who's collecting all the data and keeping us organized. And she's doing an amazing job. I'm going to show you one of her great pieces of work here just momentarily. Next one is lens defined. So and we'll go back here later on, but where is it here? Just bear with me. I have a lot of things here. Just bear with me here. There it is. So, so what you'll notice is the white paper, as we talked about in the last meeting, is split up into 10 or 11 categories. I think it's 11. And yeah, it's 11 categories. And these are lenses of expertise. Now, we can add more lenses of expertise. This is just, you know, this is just a starting point. Maybe it's less, maybe it's more. You notice there won't be anything specifically for MEP or what have you. And we feel that those mechanical and electrical would come up with various locations. As an example, lens experience, you know, you'll find scheduling, you know, things of means and methods and stuff like here. That would be in section 8. Now, these sections are sections of the white paper. What that means is that we'll have to go in deeper. The white paper is not going to go in incredibly deep because we still need to explore. But it's going to create the structure of which we emphasize momentum and direction of refining process. And every process that we have has to talk collectively to all of these equally strong from the beginning to the end, because remember, it's that transferring data from, you know, fast from a verification stage all the way to the beginning. So there's no recalculation on things. And so although the Gantt chart isn't done, here are just to kind of give you an idea that that some of these so the expertise, and I'll Jeffrey, I'll use, because you brought it up, I think it's a good one, is integrated project delivery. Well, integrated project delivery arguably is probably emphasized and more, not saying it's less important at the end or in the middle or whatever, but it's really important that is dialed in at the very beginning, because that sets the journey. And so as an example, you know, these inherently probably would go, these lenses would go through the entire cycle. And remember, just to review, pre-launch, post-launch, deployment, in other words, payload, and then it has to, either through another spacecraft or whatever, it has to then be eventually sitting on the moon surface, staged to be placed. And, you know, just sounds easy. It comes out of the mouth very easy, but if you think of all the complexities, it's quite daunting. And then execution, and also life cycle, which would be demobilization and maintenance, and then decommissioning, and then eventually demo, which they wouldn't waste anything on the moon. It would be re-scrapped or repurposed. Everything would be repurposed, potentially. Okay, so I think it's important that we understand the lens. So I would like the team to really think about, you know, what is your lens of expertise and what do you want to focus on? And if it's not here, that's all right. No problem. Let us know what lens we should have. And we don't want too many lenses, because we do have to kind of focus areas. But we would like peer review to be in areas that you are an expert in or that you've practiced in. And so mine, as an example, would be estimating. It's not project management. It's estimating, unit cost theory, you know, verification as data. I'm just using this as an example. I can't speak to anyone else, but, you know, you'll have to find the rationale and relevancy of what I'm saying to your own case. But for me, then, would be verification of data. What do I need from that to fit to the unit costs and the analysis that we use? Now, what's important about that is now other groups, the ones that are, you know, MEP and integrated project delivery, they have their expertise that's very tied into mine, but I can't comment as much as I can comment on estimating. Same thing with verification. I can understand what I want, but I, as an example, using this as an example, of course, I don't know the technology, of course, well enough to really be to have a relevant and productive and credible peer review. We want experts. So be thinking about, when you start your peer review, what lens are you going to use? You know, what's your expertise? What's your passion? What do you want? You know, what are the things you see the most that are blatant holes in our current process, and you feel that it needs to be shored up? So just be thinking in that, and it's okay to go 2 or 3, but, you know, remember your time. So, but we wouldn't expect everyone to just review the whole paper, all right? Because we would have experts. Now, with that said, the lens definition. There's in the data room for all of those lenses, there are definitions of what that means. So, you know, when you see the words, what do we mean by that? What do we mean by integrated project delivery, and how it's applied in this in our venture of what we're doing, our venture. And so read those definitions. And then the other thing is, and Anne, maybe you can get this organized, is we'll need to, I think it's in one of the surveys, but we'll just, Anne, maybe you can confirm this. We'll need to understand, everybody on the team, even if you're just a bystander or whatever, we would like to understand, what is your chosen expertise? What do you, if you were to peer review and you had time, which lens would you do it by? And if you don't see a lens, let us know what that is. And the reason is because the team's it's a quality team, but it's getting pretty big. And one of the big things we have to be careful about is logistics and making sure we don't do things twice or it becomes a burden on you to do this. So what we'll do is we'll have a document on there that you can just fill your name out in, what specific lens of expertise you would like to be part of. I think originally when we filled out the first survey of what's your expertise, I think we were putting all sorts of stuff, which we'll use that, or in other words, are you an architect? Are you on and on? That's your background. But now we want to understand, what is your expertise? What are you an area, a knowledge area leader in? So we can understand if our peer review have holes and experts that are going to review it. Okay. And then we would also want to understand whether it's a private company review, public company review, public agency, aerospace, whatever, but we'll figure that out. Main thing is understanding what expert All right, let's talk about white paper schedule. Our next meeting, we'll have a draft. I'm not sure if it's going to be 100% done yet, but we'll have a pretty complete draft. Did you hear? I'm not committing to the word complete, but we'll have a substantially complete draft for us to review our next meeting, which is not next Friday, the Friday after that. Okay. In our last meeting, I said peer review would be about 2 weeks. This is talking to colleagues. I got pretty much thrashed on that idea in a good way. I love when people poke back at me, and that's very healthy. The reality is we won't be able to do a peer review in 2 weeks. It's not fair to everybody on the team, and we need time to really ruminate about this. And 2 weeks isn't, we don't have a deadline. NASA or Johns Hopkins isn't specifically saying be done by this time. We just need more. I think we need to afford more time. And so what we'll do is at not this Friday, but again, our next meeting, I guess, 2 Fridays from now, we'll discuss the schedule of peer review and the stages of which peer review goes through, so we can get a final paper. Now, we don't also want this to be so, hey, Jennifer, how are you doing? It's good to see you. We don't want this to be in a situation where the peer review just drags out so long that we're missing the opportunity to make such an impact. I also want to remind everyone that everyone on this team, me, myself, the University of Davis, so far it's not funded. This is nonprofit. It's just we are all contributors to this amazing study. Not saying that eventually we won't get funded because there's some discussion there, but at this point there is, and I think because it's for where we are right now, I think it's probably the best scenario to keep politics out of it and what have you. This is literally a passion of love that we all have, and it's pretty profound. I think that's why we're all here. So stay tuned for peer review schedule. Again, the draft, we'll go over it next meeting. All right. I'm just looking at main theory, interaction. Okay, so let's just go ahead. And before we go on, Jennifer, I know you just came in, and we all kind of, as we get into the meetings we've had, this is our third now. And we're all, as I mentioned, we're all managers and what have you. So all of us can't make the meetings, so we're really good about recording them. And so what we want to do is when hopefully everyone reads or listens to the recording, so we don't fall behind in thought and theory. That will be problematic, so just please heed my warning there, especially if we do peer review. And I want to reiterate, doesn't mean you go through the entire recording and hang on to every word. Just move through to get the meat and potatoes, and then stop at the points you think are relevant to you. Whether it's 5 minutes or the whole thing, that's up to you. But if you're new and you popped on late, at least the first time you come on, introduce who you are, what your background is, and what interests you about this study group. And Jennifer, it's good to see a dear colleague and great thinker, and she's an expert in cycle jumps. So that will be exciting for you to give your input on that. Anyway, Jennifer.
Well, sorry for being late. I've been really excited to try to sit in on some of these meetings and find out what all is going on with this project. My name is Jennifer Taylor. I'm with HDR. I'm an architect, and I do, kind of specialize in alternative delivery. And I've worked with Paul and took his year-long course in estimating. So I'm, pretty interested in particularly conceptual estimating and how you estimate things when you don't have, all of the documents to go on. And so this seems like a really just very exciting endeavor to try to think about alchemy, exactly. And so, yeah, I couldn't resist when Paul reached out and said that this was the topic of his new endeavor. And so to what extent I can be involved, I'm going to try to. It's been a little challenging so far, but hopefully I'll be able to get caught up a bit.
Yeah, any little slice of brainwaves we can get from you will be awesome. So I know you're real busy. Okay, great. Anyone else that came in late that'd like to introduce themselves, and then we'll move on to the meat and potatoes of the meeting. Okay. So most of you, so that's the board behind me. All right. Now it looks daunting. I'm going to show you something, and this is going to spotlight Anne's work because she transferred this electronically, and we'll use some of this on the white paper to explain flow and stuff. And I'll explain this more, but I want to reiterate, this is the structure, the main structure of flow and process that we're going to be kind of structuring the white paper around. And with that said, and I don't want to necessarily go over this because it's just writing and stuff like that. We'll use the electronic document, but each area has, for instance, can you see my mouse move? Okay, perfect. As an example, you see this right here. Well, this is this is time. So for now on, everything we discuss, it doesn't matter what we discuss, it doesn't matter what lens you're on, where your peer review expertise is, everything's over time, because time is what matters. I want to remind you, an astronaut every day, we're calculating approximately for every one astronaut, $8 million a day for support. And plus, the logistics of getting supplies and material and things of that nature. So, so it's important then, that this section here so it's important then that we put a time delineation over every conversation, because in this theory, nothing is stagnant. It's always moving. It's always measuring. It's always verifying. And so how that's set up is at the beginning, and that's where IPD is going to be very important. We mentioned before that there's some amazing work, and some of you, matter of fact, Jennifer and Jeffrey, and maybe several others. I know Felipe, engineer, couldn't make it today, but he's also an expert in IPD. And so the industry on the aerospace, they're not so much, right? Because it's not part of that structure that's being practiced in now on large mega projects like hospitals. And so we have a lot to go by as far as how the industry goes. But so this is very important. The next one here, is unit, all of this process, part of the process about units and what have you. I'm not going to go through each one right now. I just want you to know that each of these sections have another piece of component that we're all tied together, but we also rely on each other and we rely on everyone's expertise to have a consistent unit or a consistency of our perception of reality, projected and verified. So I just wanted to show you that. I'm gonna go back to the Gantt chart one more time, and these now and all of this spreadsheet will be in the data room, by the way. So all of these things you can pop in and kind of look around. But the Gantt chart, as I mentioned before, Jennifer, was probably prior to you being here, these are the 11 categories of the white paper, and we'll put priority on this. But you can see the process will need to be identified. Where does that process run into your expertise? And what do you need from, let's say, the verification AI a platform that NASA is doing some experimentation on, which that paper is in the primary data room. Exciting, very exciting work. But anyway, so I just wanted to make sure you understood kind of that idea. And then I'd like to now go to what Anne did, and she took the board, and I think this is just fascinating work. Here it is there, and she put it to a electronic thing. So what I'm going to do is I'm just going to kind of walk through this. Now, there is, by the way, other sections in here that couldn't fit, and then this is these are all the theories that we're using, and this is going to grow, of course. But this is another section here, but we're going to just focus on this one right now. We're just going to kind of talk through it. I'm looking at the clock, and I only want to spend about 10 minutes on this. And I'm almost thinking that I may have a core team that understand this, and we may do a Zoom meeting with just the core team to discuss this, to get everyone really up to speed on this, and then we can have more debate and what have you. Ideally, I don't want to go into peer review without folks really understanding kind of, is this broken? Does this make sense? So what is this? So if you notice here, I think the most important thing is this time element. So time elements are, I'll give you an example how important time is. Now again, I've said this several times, but I just want to emphasize this. I'm about to say things that I feel sometimes a need to go back to the beginning and premise everything to go into the next side of the theory. And so that's the importance. If I can, in my mind, just assume that everyone at least went through and looked at the previous, just pounded through it, went through your meat and potatoes of the things that you think. And if I can, like, in my mind, learn not to always start at the beginning every time and get people up to speed, that will make things go quicker. So as we recall, the symmetry of units are the same at the beginning as they are at the end. We discussed that, and you have visual on the sheet, and we've talked about it before. So at the beginning, typically well, I won't even say typically, I'll just explain that we're not going to compare it to anything. That's up to you guys to compare it. At the beginning is where the entire team is put together. So remember that the technology is still being developed. So we don't know the technology yet. We don't know what we have options, maybe what habitat or the habitats are going to look like, or what type of construction they're going to, methods are they going to use for making roads and things of that nature. We don't know yet, but we're going to have to find out. And but no matter what it is, there's going to be a series of unit costs or breakdowns that we have to think strategically at the very beginning that has a complete picture, 100%, to the end. And the only way really to do this is using the model, I think, well, when I say I think, it's consensus of the team, is integrated project delivery, which means that, there could be the electrical infrastructure, and all their problems. As an example, lunar night is very long. And so you can't use solar panels. And so there's technology, as an example, we'll use satellites that orbit the moon and follow. So when the lunar surface is at night, the satellite is reflecting sun with a high energy laser beam that goes to a receptor and charges batteries, things of that nature. Those type of technologies have to be developed, along with excavating machines and things of that nature, with such extreme conditions. The point being is that this is a big deal, and there's probably thousands of people involved with just this. And I would say of those thousands of people, probably less than 1% know anything about estimating. And so we really have to be involved in each team, how they're developing, what information do they want? How do they want the information to look? When I say when they have a technology, how are they going to verify that the cost of the technology was accurate? How are we going to verify as we're designing that the production on the moon is going to meet the projections? And we feel that to keep everything in its symmetry line of how we code things, means that we think of the final estimate at the beginning. I know that's counterintuitive to most of us, but it's not impossible. We do it all the time in complex theory with estimating, certainly on complex jobs. And but it really does emphasize, though, the need that the master estimate is just not one entity. It's not just NASA. It's not just the general contractor, or speaking in Earth terms, but it's all of us. We all own the master estimate. It is a language for all of us, and we need to explore the language. I want to also emphasize one time as well, is that NASA has a work breakdown structure that we feel is perfect for this. They were very intuitive when they refined it. It's a couple of years old now. It's on the data room. It's under primary read, and it's infinite. We can keep going. Now, why that's important is because when we're at the beginning, and this is time, when we're at the beginning, these units, I think I've said this before, but I'm sorry, I have to say it again to prove or to convey a point. When we teach estimating, or we talk about estimating on Earth, we say, well, we don't count the screws in drywall. Yeah, you count we all know why, right? Too much information. Well, on lunar surface, we not only count the screws, we count how many times you will need to turn the screw to get it to a specific specification for a go, meaning that you have integrity between two systems, because they're going to be prefabricated systems under very extreme conditions being placed together. Now, maybe this means that they install 2 modular units in orbit of the moon, so they don't have to worry about wriglet, and then deploy it down to the surface at its place. Don't know. But the point is that systems, instead of thinking of that metaphor where we have to count all systems, even screws and the turn, think about all the things we have to track. It's mind-blowing. So we're part of the white paper will be addressing how do we verify. And one of the ideas that's been floated out is that each component, no matter how small, relevancy, we don't want law of diminishing return, but each component, no matter how, if it's relevant, small to a point, will have a code that as an example, the screw will know on an XYZ coordinate where it needs to be and when it's there, because it's encased in a system. And then once it's there, it's verified, and the journey of where it goes is verified in real time thing. Now, that is in the code. So in other words, the estimate literally will have a 3-dimensional component to it. Because otherwise it will be literally so overwhelming for humans to understand, how to track things. So that brings us to then this section here is, working IPD, and this section here is figuring out what type of units does each section, not just the builders or the folks that will be, they'll all be astronauts, so they'll be scientists and things of that nature, maybe with some construction background or some training or what have you. And just let's pause there. I want to mention one other thing. There will be a lot of robots and autonomous apparatus there, but there is a delay. And so it will be problematic to run remotely all the time. People would say, well, we don't need to be on the moon. There is a delay, and a delay could be catastrophic when you're working in real time. So that aside, understanding from lenses what information and the units, how do we break them down, and helping the IPD teams understand that for all of their lenses, through the different technologies and things of that nature. Then the next is once these units are articulated and under the NASA work breakdown structure, and that's IPD is a section. Even you'll notice that's a lens. How we break down unit costs, that's another lens of expertise. Now, once that's done, then we go into verification, and that is an expertise of, I would say, people like Dr. Figueroa, who's with NASA and a brilliant scientist. And his paper, by the way, is in primary reading. It's not that big. It will take you probably 20 minutes to read. It may take you longer to grasp because it's amazing. And I've had a privilege to talk to him about an hour or so, and so I have other perceptions that are going on when I read it, but it gives you a really good overview. What we like about it is that it has the capabilities when we work together to meet the challenge of verification from all systems that are locked into the whole entirety of its system. And also it uses artificial intelligence as well. And it's a platform that's used in the Defense Department quite a bit. It's a predictive analysis. But Dr. Figueroa's work turns it on its ear. He's disrupted the direction of that and has put another dimension of the human factor in it. And it's more intuitive, and also it talks to all sorts of technologies, and it also can talk. We feel we think, we speculate. It can talk directly to the master estimate, and that is huge, because we're not talking about in Earth construction where we do iterations every month or every week or every 3 months. It's a steady stream. It will be a steady stream, real time, all the time. And so that brings us to kind of this loop here. You'll see this loop of a we call it full cycle, but this loop is a two-way flow. So think of the top part as the information moving in the estimate and how it's put together. And as soon as that verification is made, so when that screw that we talked about, you have to figure out where it is and when it is. Once it's verified through the verification system, and it's a G2 platform, by the way, that's modified by NASA. Once that is understood to be at its place of rest and it's a go, in other words, if it's at its place of rest, but it's not the specification, it's not done yet. So as soon as it's a go and it's not going to jeopardize, it's where it's at proper specifications, that's then recorded as or sensed as it's done, which means the probability field of it being late or not making it or something going wrong collapses to what we say 0. It's inert now. And remember its journey up to that point, who knows what could happen. And remember that screw is part of a system, and the system is part of semi-systems, and on and on. And conversely, unit costs are macro and micro. They're not just unit costs. There's a hierarchy of it, way more complex than uniformat and master format that we use in estimates and management for breakout. So please note the launch and post-launch things of this nature. Again, this will be on the data room. And it will be way easier to read than the board. Next is AAR. Now remember, AAR is awareness of actual reality, which means that we're predicting reality, but we don't know what reality is until it's verified, okay? And so once we understand that the screw then is at a very specific part of its journey and it's at rest, then there's 0 probability of it being late or what have you. As soon as that happens, then we have an awareness or an actual reality occurred. We could be aware of it or not. If it's not something that we track, maybe we're not aware of it, right? So it's not just the fact that it happened, it's the fact that we're aware that it happened, and we understand what that means full cycle. Now, the reason this is important is this, if we just grasp one thing, just this main thing is going to be really important, and here's why. Because understanding where each unit goes in its journey is going to be mission critical for us, and there's a new term we're using, it's called absolute minimum variance. And that's what we want the estimate to be, an absolute minimum variance. In other words, is it going to be exact? No, but we want absolute minimum variance. 30%, 20%, 3%, 1% is unacceptable for time and cost in this condition. Can we achieve it? Only time will tell, and the industry will be judge of that. But the point being is understanding, that mechanism or the flow to the very end. And I think I just lost my train of thought here. I may have rambled just a little bit too much on that. So that's self-awareness there. But this here is going to be pretty important, that flow. Now, one other thing is we're calling it a two-way flow because there's two. Oh, I know what I was going to say. My apologies. Is that we're not just going to show up on the moon and build a habitat. We're going to and you do a large construction project. There's going to be little bits of things that they do. They'll bring up like test technologies. How does it perform? Things of that nature. Well, these are opportunities, and we have, presumably that this process here will help the design team and the engineers and scientists be more understand the predictive nature of time and cost as these protocol or prototypes are tested on the moon. So this is something that doesn't wait until the whole structure is constructed, even at test modules and things of that nature. This is very valuable information for the innovative teams that are coming with the technology. And it's also important for NASA for historical cost of production, because now they are thinking about production. They're in a new era now. Okay. So I'm looking at the time. All the other stuff here is essentially has to do with the two-way flow. So what happens is we have a prediction verification, and the verification kicks it back the other way in the same coding. And so think of it as, what did we predict at all these times when predictions are changing? But we always have our main prediction that we started with. And then what's the new prediction based on all the information that's going on? And then, but it's a prediction. And when the probability collapses to zero, we're at no variability. It's real. Then that real answer goes back and gives a indication or a bearing or a calibration for the next time. And so in general, that's kind of the way the theory moves. So I'm gonna, it is 2:00. I said this would just be an hour, but I want to just maybe, if you have to jump off, that's great. But I wanted to start with, is there any comments in general about this? I know you got to kind of wrap your noggin around this a little bit, and or any suggestions on the white paper will be out. It will explain this. The other thing to note is when the white paper comes out, it's not going to dive too far in the weeds about IPD. It's not going to go too far in the weeds with, verification technology and things of that nature. It will touch on it, but it won't be solving the problem. This is a massive thing, and it's going to take a while, and it's going to take expertise, the experts that are on this call, and many more. So I'm going to pause there and open it for comments if anyone would like to chime up on anything. Yes.
Quickly, you mentioned that the white paper needs to go out next week or in a short time period. Who is spearheading on that one? Who will start to draft that? Do you need any help on that one in general? If you can talk about that.
Yeah, you missed the email. I had you down for that. No.
Nice.
So
That should stop all future questions.
Yeah.
It does.
Oh my word. Yeah. Everyone else, like, their hands go down, Yeah, thanks, Amir. I think I was talking to several colleagues, and what we think is, again, I want to emphasize something. Just because I'm, presenting this to you doesn't mean I'm the author of this. This is so many people have contributed thoughts over years. Jennifer and Amir, you and Colin, and just so many people. So, but the board this kind of captures everything. So what we're thinking is I'll be the author on the white paper draft, because I have a good understanding of how these ideas are kind of coming together. And then it will be an organized thought. It's too chaotic, I think, for us to say, okay, you write on this, and without really understanding, the full theory. And then what we'll do is reassess in peer review, and then that's where we have to maybe expand, because from a white paper, there'll have to be other offshoots of, well, how is verification technology with the G Suite system going to talk to the master estimate, but we have to slice and dice and pick our battles, of our articulate flow, so we don't get out of true with application. But I heard a word like, I'll help. So maybe you and I, Mir, we talked quite a bit throughout a month or so. So maybe I'll run a bunch of stuff by you, and see what your thoughts are also, as I do with several people on the call. But good question. Thank you. Any other?
I got one, so I have to hop to another meeting, but I just thought, has there already been some thought about the work breakdown structure for the lunar base? I saw the examples in the documentation on their WBS from NASA. It was very specific to, I think, payload and space vehicles and that kind of stuff. This is more of a, building project. I was just curious because it feels like, I tell people all the time, try to have one decoder ring for things, because when we have multiple decoder rings, then we need decoder rings for our decoder rings, right? So I'm kind of curious if somebody has already thought about work breakdown structure, because part of me goes, why not look through the lens of that when we're thinking about breakdowns and stuff like that? So I'm curious if anyone's been playing with that.
if someone has a comment, I'll absolutely chime in. Very quickly, Kyle, is yes, we have thought of that. The work breakdown structure from NASA is not one that we're going to be, it's the girth or the length of how we can organize the coding for each unit. And not necessarily how we're going to organize it in units. So as an example, habitat may be just like we do here on Earth. You know, if it's a hospital campus, maybe we go east wing, west wing.
Sure. Pie
MOP,
slice.
you know, dice and slice. And then, you know, only systems are going to be more intense. So east wing, west wing, what fits in the middle, who has that. It may be a transitional unit which has everything related to a connection of two systems. So did that answer your question?
Yeah, I mean, I was hoping we weren't going to try to put new wine in the old wineskin of a space shuttle WS, because that seemed like it would be very difficult.
We won't. And I would you would be you have expertise in many things, and I would really appreciate not only on the verification side and the AI side, which is you're an expert in, but I would say if you can maybe have some input on the unit theory side, you could really add some value to that, because you're spot on. We need to address this, and if we get that, if the theory gets that wrong in the application, then downstream it gets real messy. So it's a big deal. Has to be really poked and prodded. So, but great question. Two really good questions. Are there any other questions or comments? Going once. Going twice. Okay. What is, someone give me a profound takeaway that was interesting to you at this meeting, and then we'll, anyone?
Quick takeaway, Paul. I think you just highlighted that the assembly cost estimating doesn't work on the moon. We need to go in detail for every component, which was interesting.
And that also highlights, thank you, Amir, a very good comment. And it also, your comment also highlights as well the importance of understanding how complex that unit cost is going to be and how it's broken out, and how important it is we figure it out at the beginning, because it will be behind the eight ball. And verification, what does that data mean? If it doesn't talk to the beginning like that, then it will not catch up to how bad things can get in such extreme conditions, how fast and bad things can get in under these extreme conditions. So that's why it has to be that. So a good comment, Amir. Yeah. And that will be a very important, that's this part here.
Oh, quickly, is there any unit cost for this exploration database like that we can look at it? Because the regular database that we are using doesn't address any of these. The material we might be able to find something there, but like the cost of the spaceship, like going to the moon, we don't have those information. I'm sure like NASA probably has some database that we can start looking at.
We do we do have access to stuff like that, and if you have a request like that, let us know, and then we can reach out to NASA, and we can just simply get the information. The other thing that you highlighted, which I want to, and again, if you don't agree with this, anyone on this team can say, no, I don't think so, and challenge. Everyone on this team should be poked and prodded. But there's something that I think we should maybe think about is we're not thinking about cost right now. Like, what does it cost to build whatever. We're thinking about the structure. If we have the structure and the units figured out, then we'll put in the cost, because if we think about the structure and we say, well, how much is the screw? We don't know what the screw is yet. We don't know how much it costs. it's not, maybe that screws $50,000. We don't know. It can't be made out of, it has to be for, for the condition on the moon, right? And so I think we, in this paper, at least from my perception and other colleagues, we were thinking about just focusing mainly on structure, how that's articulated. And then that makes it easier for estimators and teams to start inputting cost based on information and data that we glean from the structure. And you can disagree or agree with it, and we can go whatever direction the consensus is, but right now that's the direction we're leaning to. Did that answer your question, or at least satisfy your thought?
Absolutely. No, I hear you, Paul. The reason probably I asked for those unit costs gives us an understanding what they're thinking about, right? So
I see.
so it gives us like what component should we look into that to some extent, because this
Right.
is a new endeavor that hasn't been done, but to some
Yeah.
extent that they have done maybe 50% of the past, and it can help us to understand what they're looking into that.
I see.
If it
Yes.
has been established before.
Yeah. I'm going to put this down, and Ann, maybe you can make a note of that as well. I get your question, and I think it's a very good one. What are some examples? We have example from the 80s, which is just a bunch of stuff that you wouldn't approach it nowadays like that. And so why don't we we'll reach out to NASA and try to get like one that was done within the last year or something like that, a complex one, a big one. And maybe we can use that as an example of, how are they using it. But remember, NASA is brilliant at estimating when it comes to first problem, where it comes to, how much will the fuel cost based on a certain payload of weight and things of that nature, and weight of the spaceship and things like that. They can that's really good. But when we get into the construction stuff, they just don't have the bandwidth experience in that on that side. So I think this would be a really valuable. Just know that when we see that structure, it doesn't mean we're tied to the structure. We're just tied to their work breakdown structure. And but I agree with you. I think it would be very valuable to have, and we'll try to get that in the data room here within a week. Thank you. Good comment. Any other comments? Okay, with that, my apologies that this went over 12 minutes. Thank you so much for everyone that stuck with us. And all of this stuff will be in the data room. For those of you that couldn't make it, I'm glad you're watching the video here. And this is very exciting. What's exciting is not only what we're doing, but that we get to work with such amazing people like everyone on this call and the other folks on this team. It's just a fun group. So it's a privilege to be your colleague. So with that, I'll see you in 2 weeks. And I moved it to 1 o'clock. I hope you're okay, because there's Eastern time, and it goes past 5:30 to them, and that's not good. So
To meet everyone. Have a good day.
Thank you. It's good to see everybody. Bye-bye. Hey, Keith and Brad, how you doing? Brad, I don't know, Keith, are you there or what? Or are you on a phone call?
I'm here.
Okay, good. So I wanted to introduce you because Brad is a dear colleague of mine, and Keith, I think you knew this, but Keith and I go back. He's older than me a little bit. He's like a couple years older. He graduated maybe 1 or 2 years before I did. And so we go back since high school. Isn't that interesting? And he's a jazz musician. I think you already knew that about him. So
yeah, I think during the last meeting we talked about that. So
yeah. So
Yeah, I think it's junior high, Paul.
You're, you're right, it was junior high. Oh my God, I feel so old now. But
You were in junior high. I was in high school. So
yeah, that's right. Yeah. But you don't look older than me. So just FYI. Do not NOT. So
do not.
yeah.
Okay,
Oh my
I'll-
God, I would never. No, 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 no. Just because when you said that, it's like, yeah, you're right. Yeah. No, you aged very well. So anyway.
what happened in the first 15 minutes? I had a meeting, so I missed the first 10.
Yeah, a couple
Okay.
folks introduced themselves. We talked about the TV show that we've been invited to. It's
Yeah, I saw that.
Advancements. Okay, all right. So you didn't miss a whole lot. We waited about 5 minutes for people to show up, and so probably a couple. I think advancements were current event was the first real thing, so you didn't miss much. So
Oh, okay, great.
yeah, how's it?
Well, I appreciate it.
Yeah, you bet. How's it sound to you? Sound logical so far?
It's a lot of detail to go through.
Yeah, I
And
know.
but I think it needs to be done. It's part of the exercise. So
Yeah,
I
agreed.
appreciate it.
Yeah,
I wouldn't want to be you.
it's fun. It's so far so good, But
But
the paper will be a little tough, but that's all right once that's done. I think
should be
yeah,
fun.
yeah.
Hey, I'll be in Vacaville for the jazz festival. So in about a month.
Yeah. Looking forward to maybe you and I can play a gig or something while we're there.
Yeah. Let's see. I've got 11-1 spot at Max. Was it Maxie's?
Oh, Maxie's, yeah. Yeah.
So if you want to play tenor,
Well, you if you invite me, if this is an invite, I'm there, man. I love playing with
yeah,
you.
it's an invite.
Okay, well, I'm there. Any opportunity I get to play with you, man, consider it a go. So
Well, great. Just get your fake book.
okay, my fake book's right here.
Yeah, right.
So no, I'll probably know most of the tunes, but I'll bring some stuff. So looking forward to
Okay,
it. Well, what's the date?
great. September 20th.
September. Oh, okay. Yeah.
Yeah.
I'm in, man. That'll be fun.
Okay.
All right. Thanks, Keith. I'll talk to you later. Good to see you, man.
Yeah. So far, I don't know who the rhythm section is. My brother's putting it together. So far it's you.
I bet you it's that guy from Sacramento. He kicks bass, that older guy. He's really good for straight ahead jazz,
Oh yeah. But
Usually
well, hey, I'll let you guys go and
Okay.
take care, and we'll see you at the next time.
Okay, thanks, Keith. Looking forward to the 20th. Bye.
Great.
Oops. You know what? I just noticed I'm gonna stop. I forgot to stop the recording. Sorry, folks. You heard our musician talk. I'm gonna turn it off.